Good morning, dear students. My name is Ferhan Mazher, and today is 27th April 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. It's Cambridge O levels physics, and the code of the subject is 5054. Today, we have set our hearts to solve a theory paper. A paper of alternative to practical, and we call it ATP paper. We also call it paper 4. Today we have selected October November 2014 4-2 paper. This paper 4 belongs from the zone 2, or you can say the variant 2. The time allowed for this paper is 1 hour, and the total marks for this paper are 30. So let's start today's paper. So on your screen, you can see October, November 2014 4-2 paper showing up. This is paper 4. The time allowed 1 hour, 30 are the marks. A student uses a small plotting compass to investigate the magnetic field due to a bar magnet. The student places a piece of thin card over one end of the magnet. So this is basically the bar magnet, and on one of its ends, we have put up a card, and here is the top view. So below here is the bar magnet, and this is that paper. So describe how the student can use the small plotting compass to plot the shape of the magnetic field on the card. You may draw on the figure 1.1b if you wish. It's a 4-mark question. So this is basically the boundary of the end of the bar magnet. So I will place a compass here, a plotting compass here. Wherever the pointer of the compass will point, I will put a dot on the paper, coinciding with the head of the pointer, and one dot I will put on the tail side. Then I will move the compass before that point, which I plotted here, so that the pointer of the tail of the pointer of the compass coincide with that dot. And wherever the pointer will point, I will put a dot on the paper, and I will continue this process until I reach the end of this paper. Then I will join those points with a line or a curve. Then I will put the compass on a different location in the center of this paper, and I will repeat that procedure, and then I will join those dots. So this is the 4-mark question, and this is what you will do. So let's have a look at what I have written. So here you can see I have shown on the figure that how we will do this. Put a dot here, put a compass here. Wherever the pointer of the compass points, put a dot, then remove the compass before that dot, and the tail should coincide with this. Wherever the pointer points, put a dot until you reach the end of the paper. Then start and then join those dots with a line or with a curve. Then start the same procedure from a different location from the center of the paper. So this is what I have written, and you can see, place a plotting compass on paper, put dots on the paper coinciding with the tail and the head of the pointer of the compass. Move the compass so that the tail of the pointer coincides with the previous dot. Continue this until end of the paper. Join dots with the line. Repeat the same procedure in different directions starting from the center of the paper. So this is my answer. Hopefully you understand. So let's have a look at the marking scheme. Dots mark cross at one end of the compass needle. Move compass to the point to the previous dot. New dot, repeat along one line and join the dots. Repeat with the different start points and more lines. I hope you understand. Okay, so we are moving to the next question. He says, explain why the plotting compass must be small. If the plotting compass will be small, you can put more dots on the paper, and the more the dots you put on the paper, the smooth will be the line and the smooth will be the curve, which represent the magnetic field line, and it's easier to maneuver. Okay, so smaller plotting compass will make more dots on the page, so curves will be smooth. That's my answer. So let's have a look at the marking scheme. Anyone from more dots, dots closer together, smoother lines, field due to the compass small. Okay. So the next part. Apart from the shape, state what else can be deduced about the magnetic field with this apparatus. You can decide on the direction of the magnetic lines. You can also decide that which pole is under the page, and you can also decide that how is the magnetic field strength. So let me show you my answer. I have written direction of the magnetic field can also be deduced. So have a look at the marking scheme, what the marking scheme has to say. Anyone from direction, strength of the field, which end is north, south, the poles of the magnet, where field is stronger. Relatively, you can tell. Where the magnetic lines will be close, there the magnetic field will be stronger. Okay, so we are done with the question number 1. Okay, so we are going to do the next question. The next question coming up on your screen is question number 2. A student investigates the use of pulleys to lift a load. The student uses 2 pulleys A and B to lift a load W as shown in the figure. So here this is a pulley A, which is a fixed pulley, and this is the pulley B, which is not fixed. And this thread, this rope is going around this pulley and then around, and is connected here. And then with the pulley B, we have hung a load W. So this string here basically is lifting the load of the pulley B and the load of the weight W. And this Newton meter here tells you how much is the force being applied here. So from this meter, I can tell how much is the load being applied, how much is the force being applied. So the student uses a Newton meter to measure the minimum force F needed to raise the load. The student raises the load at a slow, constant speed by pulling on the Newton meter. Explain why the student uses a constant speed. You see, if you move the pulley slowly, if you pull it slowly, the reading on the meter rule will remain constant. If you give it a jerk and the pointer of the meter rule will, I'm saying meter rule, sorry, I'm saying meter rule. It's Newton meter basically. You move it very slowly. The reason is with a constant speed. The reason is you do not want this pointer to shake, to vibrate. You want it to remain steady. And that is achieved when you move with a constant speed. So that's a reason for using a slow constant speed. Why we use a slow constant speed? So that this is steady and you are able to read. So you are able to read the reading on the Newton meter. By mistake, I used the word meter rule. It's not meter rule. It's Newton meter. So let's read my answers. These are 2 questions. So here we go. Constant speed will make sure that the reading on the Newton meter remains steady. At slow constant speed, reading on the Newton meter can be read easily. These are my answers. So let's have a look at the marking scheme. What the marking scheme says. It says, yeah, to measure a constant force, no accelerating force to give a steady reading, a variation in speed gives a variation in F. Anyone from have time to read the meter, easier to read the meter, easier to keep the speed constant. So our answers are right. Okay. He says that the student measures F for a load of W of 0.20 Newton. Figure 2.2 shows the Newton meter when the load is raised at a slow steady speed. State the force F shown by the Newton meter. This force is, I can check from here. This is 0, this is 1, this is 0.5, this is 0.4. Okay, so this is 1, 2, 3, 4. This is 0.45. I think 0.45 is the answer. Let's have a look at my answer. Yeah, the answer is 0.45 Newton. Then the next question is on the figure 2.2, mark the position of the eye of the student when taking the reading. Remember this thing, the eye should be perpendicular to the scale from where you are taking the reading. So this is how you draw it. It's a 1 mark question, so we are good. Okay, then he says the student takes a series of readings for F for different values of W. The readings are shown in the figure 2.2. 0.20, the F value was 0.45. So you have to write here 0.45. Because it says on the figure, write your value of the F from the B first part. Okay, so that will be 0.45 Newton here. Then the question is on the figure 2.4, plot the graph of F in Newtons on the y-axis against the W in Newtons on the x-axis. Start your axis from the origin, draw the straight line of the best fit. Okay, so you can see this reading. This reading is going to be on the x-axis and these numbers are going to be on the y-axis. They are going from 0.2 to 1.4 and this is going from 0.45 to 1.20. So this is that figure which we have to plot. And let me show you first how I have done that. So this is that table and this is what I have done. So you need to label it. So on the y-axis, you will have F, and on the x-axis, you will have W. Both are in Newtons. It's going from 0.2 to 1.4. So I've taken 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4. Here I've taken 0.2, 0.4, 0.6, 0.8, 0, 1, 1.2, 1.4, 1.6. Then I plotted the points. At 0.2, 0.45. At 0.2, 0.45. Then at 0.4, 0.6. At 0.4, 0.6. Then we have 0.6, 0.7, at 0.6, 0.7. And then we have 0.8, 0.85. At 0.8, it is 0.85. And then we have at 1, I have 0.95. We have 0.95. And then at 1.2, 1.05, 1.0.5 means 1.1 approximately. This one at 1.2 it is, and at 1.4 it is 1.2, and at 1 we have 0.95. So we have plotted these points, and then what we will do, we will join them with a line of best fit. Line of best fit, you can see one point is here, one point is here. The rest of the points are on this line of best fit. Okay. Then their questions are, use your graph to find the value of the F when the W is 0. When the W is 0. Okay. So when the W is 0, when the W, this is W, when it's 0, it is 0.32, I think. 0.32. Let me show you. 0.32 Newton is the answer. Then the question is, suggest a reason why the line of the best fit does not pass through the origin. This is not passing through the origin. The reason is when the W is 0, when there is no weight hanging with the pulley, when this W is 0, still you have to apply force to lift the load of the pulley B. If the load is 0, still you have to bear the weight of the pulley B. So at 0, 0, 0, the graph will not pass through the 0, 0. That's the reason. So our answer is coming out to be, my answer is, when the W is 0 Newton, still the weight of the pulley B will be causing some reading on the Newton meter. So that's my answer. So let's have a look at the marking scheme for this thing. So we are done with the question. Yeah, here we are. So the axis labeled quantity and unit, scales linear, points plotted accurately, best fit straight line drawn 0.32 to 0.36, allow error carried forward from the graph. Weight of the lower pulley, friction of the string over pulleys because F is not directly proportional to W. Okay, so we are done with that. Okay, so next question. Determine the gradient of the line, show your working, give your answer to two significant figures. Okay, so to find, if you want to find out the gradient of this line, so we will take 2 points on this line. For example, I have taken 0, 3.2 and 1.4, 1.4, 1.2. So I will take these 2 points. It's a straight line. You want to find out its gradient. Very simple. M is equals to y2 minus y1 divided by x2 minus x1. So 1.2 minus 0.32 divided by 1.4 minus 0. So it will be 0.88 divided by 1.4. And that will be 0.63. So the gradient is 0.63. So the gradient is 0.63. So it says from 0.58 to 0.64. So we are done with the question number 2. So we are moving to the next question. The next question is, a student is given 2 resistors of the resistance 24 ohm and 24 kilo ohm. Each resistor is marked with the 3 color code bands. So these are the colors. Black means 0, brown means 1, red means 2, orange means 3, yellow means 4, green means 5, blue means 6, violet means 7, gray means 8, and white means 9. You don't have to remember this. This is always given in the question. He says, state the color of the bands on the resistor given to the students. Okay, so that's the A part. One resistance is 24, the other one is 24,000. Okay, so here we go. So 24 means 24 multiplied 10 raised to power 0. So the first color is this digit, the second color is of this digit, and the third color is of this power. So 2 means red, and the 4 means yellow, and the 0 means black. So the colors will be red, yellow, black. So 24 kilo ohm means 24 into 10 to the power 3 ohm. So for the first 2 colors are for these 2 digits, and the third color is of this power. So it means 2 means red, 4 means yellow, and raised to power 3 means orange. Okay. So the colors will be red, yellow, and orange. So this is how you decide the color code. Hopefully you understand. Red, yellow, black, red, yellow, orange. So let's check the marking scheme. Where are both first bands red and both second bands yellow, black, orange in the third band? So our answer is right. Okay, so the next question. The student uses 3 identical 24 ohm resistors. Describe in words how the 3 resistors are combined to give the smallest possible resistance. Connect them in parallel to each other. So when you connect the resistors in parallel to each other, their combined resistance will be less than the smallest of the individual resistance. So here we go. They should be connected parallel to each other. Parallel is the answer. Okay, figure 3.2 shows one possible combination of the 3 resistors connected between the point A and the B. So you can connect them in series with each other. Their question is, let me show you the whole question. He says, in the 3 boxes of the figure 3.3, draw the 3 other possible combinations of all 3 resistors connected between point A and the point B. Okay, so here we go. So the one way of connecting them is like this. 2 of them should be parallel to each other, and they then in series with the third one. 2 should be in series with each other, and this whole should be parallel to the third one. And all of them should be parallel to each other. So these are the, let me show you. So these are the 3 possible combinations. Then the question is, the student needs a resistance of 36 ohm for this experiment. On the figure 3.3, mark the letter E, the combination that has this resistance. Okay, so if you look at here, this is 24, 24, 24. These 2 are parallel to each other, so their combined resistance will be like this. 1 by R4, 1 by 24 plus 1 by 24. So it will be 1 by R4 equals to 2 by 24. So R4 will be equals to 24 by 2, and that will be 12. So once you know the combined resistance here is 12, so this is 24, so 24 plus 12, 24 plus 12, that will be 36. So put a letter E here. This combination has a total resistance of 36 ohm. So our answer is right. So we are moving to the next question. The next question is, he says, is a student is given a cylindrical 250 centimeter cube beaker. He is asked to find the outside diameter of the beaker. The other apparatus available is shown below. 2 half-meter rules, marker pen, 30 centimeter ruler, pencil, 2 meter thin string, scissors, 2 meters thick string, and thick string, sorry, blue tack, and the plain paper, and the sellotape, and the blocks of wood, and lined paper. Describe in detail how the students can obtain an accurate value for the outside diameter of the beaker. In your account, you should state the equipment used, explain how the equipment is used, state any readings taken, explain how the value for the diameter is obtained, describe how to make the measurement accurate. So one of methods which we are going to use to find out the diameter, the outer diameter of the meter rule, is that I will take 2 wooden blocks and I will place the meter rule on a table. I will put the wooden blocks around it, as shown in the figure. Here you can see that figure. So what I will do, I will take 2 wooden blocks, put them like this, and between them I have put that beaker, and then I will put a meter rule scale, and then I will check what is the distance from here to here, from point A to point B, and that is equal to the diameter. Then I will rotate this beaker a little bit to find the same thing from a different location on the beaker, and then I will take the average. So this is how you will do this. Okay, so this is that diagram which I have used. Okay, place the beaker between the 2 wooden blocks as shown in the figure. With the help of the scale, measure the AB distance between the blocks. AB is the diameter of the beaker. Rotate the beaker and do the same procedure to find the AB diameter. Take average of the diameter. Okay. Then their question is, suggest one reason why it is more difficult to measure the internal diameter of the beaker. You see, if you want to measure the internal diameter of the beaker, that's one difficulty, is that you cannot put the scale inside the beaker. The scale is longer and the beaker has, you cannot put a scale inside the beaker. That's a problem. Scale cannot fit in the beaker. Scale also have dead ends on both ends. That can be a reason. Okay. So he says maximum 3 marks for drawing round bottom of the beaker. Equipment used stated. How equipment used explained. Readings taken stated. How diameter is obtained explained. One accuracy detail. Accuracy detail is that we find the diameter from different locations of the beaker, and then we find their average. That's the accuracy detail. Anyone from cannot fit ruler inside the beaker, cannot use string inside the beaker, cannot draw the internal circle inside the beaker. So my dear students, we are done with this paper. So yeah. So my dear students, today we have done October, November 2014 Physics 5054 4-2 paper. This ATP paper belongs from the Zone 2. I have tried my best to explain you the concepts. Being a human, I might make a mistake. I'm trying my best to use the marking scheme when I'm describing you the answers. I've tried my best to explain to you to best of my ability. I hope that you will understand this paper. If you find this video interesting and you find this video useful, and if you find that this video is helping you by sitting at your home, by watching this YouTube video, you can practice the past paper of the ATP. Please share the link of this video on your Facebook, on your Instagram, on your Twitter, with your class fellows, with your junior students, because that will help me to promote my channel and help so many other people. I'm glad that God has provided me this chance, that I am able to help so many students around the world. It's a blessing for me. Thank you very much, everyone. Have a good day. God bless you all.